today? Has everyone had fun? Yeah. I stand between you and the party, and I have 153 slides. So I'm excited. All right, so I'm here to talk to you today about a tale of two asyncs, or how language values shape the features we build and the journeys we take to design them. Just a little bit of a disclosure here. I say Node.js and I talk about language design. If you're a pedantic person who knows no language, I don't know, PR is welcome if you want, but not really. I'm going to use them interchangeably for the most part. Alright, so my name is Ashley Williams, otherwise known as AG Dubs on Twitter. If you follow me, I'm sorry. But if you are interested in Rust, WebAssembly, generally weird stuff, you can feel free to go ahead and do that. I used to be on the Node.js board of directors, and I know that was listed on this website, but as of 2 days ago, I finally officially am not. But for a really long time, I was a Node developer. I worked at this little company that you may have heard of. You may like it, you may not. I don't really care. I don't work there anymore. But yeah. So when I was doing Node, I kickstarted this program called Node Together, which was an inclusive education program for getting people from underrepresented backgrounds into programming. And this is kind of going to be a theme kind of throughout this because I really love education. I have been invited to TC39, though I have not been able to attend as much as I would like, to be able to give a teacher's perspective in the design of JavaScript, and that is also going to play a super huge part in this talk today. But currently, I'm a contractor at this company called Mozilla, and I work on the emerging tech team on Rust and WebAssembly. So believe it or not, working on an open source programming language is a lot like working at a startup. So I wear a lot of hats. I'm on the core team, but I'm also the community team lead. I do info for Crates.io. I'm also on the cargo team, and I'm also in the Rust WebAssembly working group. So that's just a couple of things, no big deal. I'm really jazzed up about Rust and WebAssembly right now, so if you want to talk about that, please come find me. This is the Rust unofficial mascot, Ferris. You'll see him a couple of times. Actually, they're not binary. Sorry, Ferris. But yeah, so instead of doing Node Together, which I passed on to the Node.js ComCom, I now help run Rust Bridge, which is part of the Bridge program. So if you've ever heard of Rails Bridge or Ruby Bridge, it's similar. And so these are just a couple of shots from the work that we do. Again, an inclusive education program focused on getting underrepresented folks into programming. And sometimes I dress up like a crab to teach it. It helps. So I love teaching programming, and this is partially because I really, really love programming languages. And fundamentally, this is because I really like thinking about thinking, especially the type of thinking that happens when people write code. A lot. I really, really love this. So this is me graduating from university without a computer science degree. I actually went to be a film major, but then got way too into neuroscience and theory, so left with a neuroscience and philosophy degree. So I share this only because we're going to get a little philosophical, and if you're wondering why, it's because that's just who I am. So yeah, the goal of this talk is to talk about two languages that I love, which is Node.js and Rust. It is not a competition. Sometimes this is going to get a little bit spicy, but trust me, I love both of these languages tremendously. So, as I said, let's get philosophical. Alright, so we're going to talk about this idea of genealogy. How many people know this dude over here? Oh yeah, this mustache is huge. Alright, so part of what I want to do today is I kind of want to walk us through this idea of a genealogical analysis. And the whole point of a genealogical analysis is kind of to get to the underlying social and political elements of various philosophical, social, or say even computer science beliefs, and then attempt to account for the entirety of the discourse. So you can really analyze what is going on. And more importantly, what a genealogy is often attempting to do is to look beyond the discourse in question to kind of think about the conditions of something's possibility. So to a certain extent, I kind of want to be how is it even possible that we were thinking about async? How is it possible that something like Node.js happened in the world? How is it possible that something like Rust happened? So this is another really awesome dude that I'm into. Anyone know this guy? This is Michel Foucault. He is super serious. What he says here is the point of a genealogical analysis is to show that a given system of thought was the result of a contingent terms of history, not the outcome of rationally inevitable trends. Now, I posted this slide to Twitter because that's what I would do, and immediately a friend of mine was like, that's the nerdiest way to say shit happened I've ever seen. But you know what? Like, it turns out that repeating this point is really important, particularly with computer science developers, because we love to reason from first principles, and we love to think of things in a not historical or not material way. We genuinely believe that we can think about ideas as if they exist in the sky alone like that. And so, again, one of the biggest things that I want to do here is encourage us to realize that we need to be looking at programming in this type of historical and material way. So, genealogy is fundamentally an investigation into those elements which we tend to feel are without history. And so again, computer scientists love to think of programming languages as just like this kind of objective thing. How many people here have ever used the word objective in an argument about computer science? Feel bad. All right? Because programming languages are deeply complex historical artifacts and agents, which means they respond to and then also change history. And unfortunately, we rarely think of them as such. So I'm going to be able to cover a little bit of this about some of the programming languages I want to talk about today, but I can't go nearly as deep as I would want to. But there's a lot of really cool information out there, and if you've never looked into that kind of stuff, you should check it out. So this is a gentleman by the name of Thomas Kuhn, and he wrote one of my favorite books ever called The Structure of Scientific Revolutions. And so he wrote, scientists work from models acquired through education and literature, often without quite knowing or needing to know the characteristics that have given these models the status of community paradigms. So fundamentally what this means is like, we're using a whole bunch of stuff and we kind of assume that this is exactly how it's like kind of supposed to be. We never really figured out why it happened. And so the question why, which is maybe kumbaya, if you've had some beers, maybe you're on this level already. But I'm going to be asking why a lot today, because I don't think we ask it enough. Alright, so when you search for genealogy of programming, you find a really awesome article that has this amazing diagram, which clearly it makes a ton of sense. And this article actually asks the question, what is the best first programming language? But this is a fill-in for a question of any type of this one, like, what is the best any type of programming language? And fundamentally, hopefully we all know this, but I've seen Hacker News, so I know we don't all know it. It's a trap, okay? It's definitely a trap. And so one of the ways that a lot of people have combated this idea of, what is the best thing, is to start talking about another type of best, which is the best tool for the job, all right? We say this a lot, but I also think that when we say something like this, we don't really have a good way of breaking down the problems or the jobs that we need to do, and also being able to articulate what it is that makes something the best for that particular type of job. And so what I'm going to ask in this is, what do programming languages want? This could be like, what is the affordance of the programming language? What is the goal of the programming language? And this brings me to one of my favorite computer scientists ever, Peter Van Roy, and he has extensive literature on this idea of programming paradigms. And so a programming paradigm is an approach to programming of a computer based on mathematical theory or a coherent set of principles. Each paradigm supports a set of concepts that makes it the best for a certain kind of problem. So we can talk about programs and the problems they solve by talking about them as paradigms. So we can say, this programming language has a certain set of paradigms because it has certain concepts that make it good at solving a certain thing. All right, and so this is Peter Van Roy. He's a ham. Oh my God, he's delightful. But what he talks about is this paradigm paradox, paradigm paradox, which is extremely hard to say. But it's worth remembering again that more is not better or worse than less, just different. So already we're kind of skirting this question of best. So he made this amazing diagram, which maybe makes slightly more sense than the other one, perhaps not, where he tries to graph out all of the different paradigms that certain programming languages are able to demonstrate. And so you can go through, and he talks about how they all relate to each other. And this type of thinking just makes me incredibly excited. You can print this out full size and put it on your wall if you want. I'm actually shocked I haven't personally done that yet. A strong recommend. So the first question I'm going to ask right now is, what type of language does Node.js want to be? And it turns out this is a really hard question to answer. not even just as a programmer of Node, but if you actually go looking and be like, what are Node's goals? It's actually incredibly difficult to find. And so I'm going to take us back historically a little bit to this presentation. How many people have watched this? All right, so this is the original presentation of Node.js by Ryan Dahl. It has some A/B problems. The slides are incredibly small, but it says I/O needs to be done differently. And so what he says here is that kind of the way we are currently thinking about I/O makes things difficult. And so this is how he is proposing Node.js. And so the first thing he's going to talk about is this idea of asynchronous programming. And so how many people here have read Eloquent JavaScript? Eloquent JavaScript is by a gentleman named Brian Haverbeek. Fun fact, also worked on Rust, small world. But he describes asynchronous programming in this book with that Tate Ching quote. He says, asynchronous programming makes it possible to express waiting for long-running actions without freezing the program during these actions. And so what I'm just trying to center us here is asynchronous programming has become an incredibly complex topic, but fundamentally what we are dealing with is just the question, what is the software doing while it queries the database? And what we're asserting with asynchronous programming is it should be doing something, right? And for a long time in a lot of programming paradigms, it was not. And so this is actually the exact example that Ryan Dahl demonstrates, so I figured I would just repeat it here. But back in the days of Bar, right? Amazing. All right. So if you go about 10 years before Ryan Dahl presents Node.js, there was this kind of original problem where we were talking about asynchronous programming, or the need for asynchronous programming. And so it's the C10K problem. And I actually had never heard of this until I was doing research for the talk. But fundamentally what this says is it was reacting to this problem where people would write very popular blog posts, and they would end up on Slashdot, which is Hacker News with the same amount of bad. The post would get so popular that people would take down the sites because they were receiving too much traffic. And so I think it's just really funny to realize that in 1999 we were saying it's time for web servers to handle 10,000 clients. Like that's a big number, right? 10,000. Simultaneously, don't you think? After all, the web is a big place now. So just to think, like 1999, I mean, I was alive then, and we were dealing with this problem, and now we're talking about, we just looked at concurrent requests in the previous presentation. I feel like we've come a long way since then, and so that's pretty cool. All right, so when we think about asynchronous programming, one of the first responses we're going to use operating system threads, and so this is a technical document that's demonstrating how threads are used, right here. And so in his presentation, Ryan actually comes out and says quite frankly that he does not care for threads at all. He says threaded concurrency is a leaky abstraction. It creates pains. You have memory problems. It's hard to think about. It is not a good abstraction for what's happening on your computer. And he goes forward to present this idea of comparing Nginx and Apache. And so this diagram has quite a lot in it, and to be frank, this design of this benchmark is a little bit dubious. But fundamentally what he's trying to say here is Nginx and Apache can deal with a lot of concurrent connections. However, Apache's memory usage grows with the current connections in this benchmark. And this is because of and so fundamentally the takeaway for Ryan here was that threads are expensive. Alright, particularly he's talking here about OS threads. If you want to talk about green threads, I had to cut that from the talk, it's too long, but we can talk about it later. And so what Ryan says is, hey, what we need to do is we need to have asynchronous programming from the beginning. We need to do it in not this threaded way. There were previous things, like in Python, Ruby had event machine, but because these languages fundamentally were really focused on threads and how they were doing asynchronous programming, having them in the ecosystem space really made it complicated because there was not really a great way to have them interact together. And so he's like, what I want to do is I want to write Node, and I'm going to use this thing called the reactor pattern. And so this is the OG diagram of the reactor pattern from the paper. If you're interested in reading it, it's right there. It's fine. But fundamentally what he meant is, let's do libuv, which has just the most amazing logo. I love it. But fundamentally what he's talking about here is the Node.js event node, which is diagrammed here excellently for you, where we are not using threads at all, but rather a single thread that then delegates to a whole bunch of them. So Alex Rauschmeyer, who I think always just has a really awesome way of describing things, tweeted this diagram and said, JavaScript is a single-threaded scripting language for a multi-threaded system. And so that's fundamentally what happens. When I taught Node, one of my favorite things to do was like, oh, it's single-threaded. You know, the event looked a single-thread. And I'm like, yes, but there are threads underneath. And it's often something that people forget. So what Ryan said, and if you watch his talk that he gave very recently about his regrets, I mean, he's not that into callbacks anymore, but he was like, callbacks is really how I/O should work. We should really be doing this kind of thing where an event happens and then we do something after the event happens. Alright, and he thought that this was really awesome because fundamentally JavaScript was already ready for this. JavaScript was designed specifically to be used with an event loop. JavaScript already had an event loop in the browser. So the culture of JavaScript was already geared towards evented programming. And so to answer the question, what does Node want? Node wants to be a purely evented, non-blocking infrastructure to script highly concurrent programs. This is its goal. All right, and he listed out all of these here, and I'm not going to go through all of these, but I think it's really useful to have this list. I mean, looking on throughout the entire Node.js repository, it's actually going to be very difficult to find this list of design goals for Node. So fundamentally, what we can understand here is that evented programming is the primary paradigm for Node.js. All right, so now we have an understanding of what Node wants to do. What type of language does Rust want to be? So Rust has a website, and its website says that Rust is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. Now, the core team has talked about this a lot because it turns out that this is not a good slogan at all because it mostly doesn't make sense to anyone. Like, this is how they read it. They're like, oh, okay, Rust, it's a programming language. And that's not terribly useful. So I'm going to talk a little bit about Rust, what Rust is used for, and describe a bit of it, and see if we can't tease apart a better understanding. So Rust was originally a systems-level language that was designed for replacing C++ in Firefox. So Rust is low-level, super close to the metal, you know? It doesn't have a runtime, it has no garbage collector, no seg faults, and it has static typing. And one of the best powers of Rust is its compiler, demonstrated here in its natural form, doing what it does, telling you no. And I really love the Rust compiler. If you're learning Rust, something that you'll run into is the idea that you often feel like you're fighting it. But instead, I like to think of the Rust compiler as actually a pair, as in pair programming is sort of built into the language. I can write code, and if I mess up, it's going to catch my problems, and then it's going to hopefully like show me how to fix them. It's amazing how many times the compiler can just tell me exactly what I need to fix. So the way I like to describe Rust is that Rust is a systems programming language designed to empower developers of all kinds to write fast, safe code. So we also, in our endeavors to be an empowering language, so we have that compiler that's going to help you out a bunch, we also have first-class package management with all of these amazing things inside of it. And we have something called crates.io, not to be confused with crate.io upstairs, which very nicely let me sit in their offices today. We actually tried to get the URL and you already had it, so that's funny. But we have a ton of packages in here. We are extremely minuscule compared to NPM, but that's fine, we're still growing. So one of the things that we started this year is we came up with this idea for domain working groups because Rust has pretty good beginner documentation and has pretty good super advanced documentation, but we really want to encourage intermediate developers to start adopting Rust. And so we came up with these domain working groups to try and say, like, what is it that you can actually do with Rust, you know, beyond writing a browser? And so we have 4 working groups for network services, WebAssembly, CLI apps, and embedded devices. And so the one I'm going to focus on here is networking services, because it turns out that kind of like Node, Rust wants to be a first-class server-side language. So I'm going to talk a little bit about how Rust is implementing async right now, because if you want to be a first-class server-side language, you got to have an async story. And that was almost always like kind of established, I feel like, by Node. Node is like, if you're going to be a server-side language, you have to compete with us, and our async story is like in our blood. So the first level of async in Rust is this crate called Mio, which stands for Metal.io. And this is what everything is built on top of. Everything is built in a way so that you don't have to touch this, so I'm not going to cover it too much. The next step is futures. So futures are our like async unit. And we currently have taken a subset of this and put it into our standard library, which is currently only in nightly, but is going to be stabilized very soon, which is super cool. And the tool that you would be using, if you wanted to be writing async in Rust, is a tool called Tokio. It's a Sierra platform for writing fast networking code with Rust. And so you can understand Tokio to be futures plus Mio. So you have the operating system level with Mio, and then the programming level concept futures. We stick them together and we get that. So I pulled this together really quick. It turns out that we don't have one of those nice diagrams that y'all have with the event loop. But I was like, gosh, we probably should have one. So this is the first ever one that I'm aware of that I could find. So it's a little bit complicated. I already apologized to Benedict for putting the line through V8. We love V8. Yeah, so what you can see here is there's something called Tokio reactor, which goes back to that idea of the reactor pattern. That's our event loop. Instead of calling it an event queue, we have a series of tasks, and those are interfaced through the futures library. And those are thrown over here, and we have worker threads, and then they get executed as they get sent back. So this is actually, like, in model, rather similar to what is going on in Node. One of the most amazing things, though, because Rust is a low-level language, each one of these pieces is customizable. So if you wanted to have a different event loop, you could pull out Tokio Reactor and put in your own. Or similarly, if you weren't amped about how thread pools were being created, you could pull that out and pull your own. So if there's ever been a moment where you're like, gosh, I love the event loop, but also the event loop is really killing me today, you could kind of write your own thing. And so fundamentally, it's really customizable, and this is because at its heart, Rust is a systems-level programming language that wants to give you control. Now, a hilarious story about this system is that because we are so focused on being able to configure it and being able to control it, one of the original designs we had for Tokio actually required that you spin up an event loop on your own. Now, this caused a ton of problems, especially for someone who comes to Rust from Node, like me. So when I first wrote my first Tokio code, I wrote everything correctly, it compiled, but nothing happened. And I was like, what is going on? What is happening? And it's because I didn't instantiate and start an event loop. And it turns out that I was not the only person who ran into this problem. So if you happen to have tried this out a while ago and ran into this, we have now learned that defaults are kind of nice and an implicit event loop is awesome. And that's largely due to the fact that Node kind of started that off, and that's super great. Alright, so if you're curious to look at what some of this syntax looks like, we also have Async await coming in for our edition in September. But fundamentally, writing a server, like a simple echo server, would look something like this. And so unfortunately, I don't have time to jump into all of the syntax. It would be a huge pain in the butt. But this is what Rust syntax would look like. So if you've never seen any Rust syntax, this is a bit what it looks like. And I don't know, I like to think that this is a pretty good solution. Again, Rust doesn't have a garbage collector, there's manual memory management, so there's a little bit more in here, but fundamentally I think we're really happy with the ergonomics of this. But we'll get into that a little bit more. Alright, so Rust wants to be a first-class server-side language, but there's a real big question here of, should it want to do that? That's kind of an unusual thing. So the question that I want to pose to us now is, should you want to write a web service with a systems level language? Like, do you want to actually write a web service with a language that you could also write an operating system in? The corollary to this question is, should you want to write a web service with a language designed to write a browser? And you might notice the elision between the idea of a browser and an operating system, because what is a browser if not an operating system? But this is a really reasonable question. I think a lot of people, when they hear about Rust, are often quite surprised to think, oh, I'm supposed to write a web application with this? I know 2 years ago, when I was talking about this originally, I was like, no way. Rust is not a good idea for a web service. That sounds like a terrible idea. But my mind has been changed a little bit. So Rust was originally designed to replace C++ in Firefox, as I said before, and this is the logo for that. So it's the Firefox engine gecko. This is Servo. And I don't know if that's actually its name, it's just its logo, but it's I can't even believe this is actually a professional logo. It's shocking. Rust, we have fun. But yeah, so Rust has been extremely amazing for Firefox. If you might have noticed, last year Firefox Quantum shipped, and it shipped with a first of its kind parallelized style system called Stylo, which improved performance and experience in the browser dramatically, and that was really awesome. And there was a talk by one of the Servo developers who was talking about some of the nitty-gritties of it. It went from 160K lines of C++ to 85K lines of Rust, and it was significantly faster, more performant, and they were able to develop it a lot faster. Now, I could have gone into the nitty-gritty details that he had there, but I think this diagram mostly just says it really well. You can see on the y-axis here, we have program workingness and over time. And so C, maybe not so much, but over time, I mean, the program workingness of Rust is actually improving here, so I'm not entirely sure I agree. But fundamentally what this says is you can write a lot more maintainable code with Rust. Now, this is a sketch from Julia Evans, or Bork on Twitter, who is fantastic. And she is a huge fan of Rust and uses Rust for tons of experiences all the time. And I love this slogan where she says, Rust makes improbable programs possible. And she finds it extremely empowering, where she's like, hey, maybe I can write that program that I couldn't necessarily even imagine writing if it was in C or C++. And she kind of on her own, without me saying my slogan, came up with, it's empowering for a wide variety of people who might not otherwise consider themselves systems programmers. And this empowering element is something that kind of turned my mind when I was like, okay, should you want to write a web service in a systems level language? And I was like, yes. I am now convinced, and it is now something that I would like to do is to convince you of that. So when we were talking about Ryan and the original goals of Node, he was describing a problem where it was this kind of trade-off between concurrency and memory. And that was one of the biggest problems with threads, and that's why we introduced async. But I think we still run into problems with concurrency and memory. This is why you can have talks like the one that I just had, or the one that just happened before me, because finding memory leaks and finding memory problems is actually like a big thing that you do in Node. I certainly know I did it at Sonnet NPM. But Rust has another slogan, which is speed, safety, and productivity. Pick 3. And so one thing I can say is Rust is definitely fast, and Rust compiler definitely makes your code safe. But one of the questions you have to ask, and this is the fundamental one that I was not sure about when I was thinking about the web services thing, was this idea of productivity. And so what does productivity actually mean? Fundamentally, this means developer experience. So have you ever felt like this? Or like this, maybe? Or this? There were so many of these GIFs, it was freaking awesome. And I was like, I don't know which one to pick because I like empathize with all of these. But developer experience is a huge thing. And fundamentally, Node has been incredibly successful because JavaScript is such a small language, it's really easy to learn and master. And programming language theorist says this about, in his Hitchhiker's Guide to the Galaxy. He says, the history of every major galactic civilization tends to pass through 3 distinct and recognizable phases, those of survival, inquiry, and sophistication, otherwise known as the how, why, and where phases. For instance, the first phase is characterized by the question, how can we eat? The second by the question, why do we eat? And the third by the question, where shall we have lunch? Now you might be like, okay, actually, why are you reading this now? I have no idea, you're just talking about developer experience. But this is really critical, because it turns out that developer experience is not some huge swath where you go, that's good developer experience, and that's bad developer experience. It's actually incredibly complicated, because you can separate out developers into a whole bunch of different stages. And so I'm going to separate them out into 3. And this is from an awesome blog post by a mathematician named Terry Tao called There's More to Mathematics Than Rigor and Proofs. And so he separates out these learners or practitioners into 3 separate categories. This idea of pre-rigorous, rigorous, and post-rigorous. And what he's really trying to talk about here is this idea that we kind of start out when we're learning something new with this kind of like blind intuition. We're kind of like throwing formalism or ideas at a problem kind of like willy-nilly. And then we become intermediate developers. And when we're intermediate developers, we really love the rules we just learned, like a lot. And we're a little dogmatic about them. We're very rarely intuitionistic, and we are more focused on the rules that we learned, formalisms we learned, and applying those and correcting our mistakes there. Interestingly enough, when you go finally to that last stage, you really return to this idea of intuition. But the cool thing about the intuition now that you're on the third level is that you already have this kind of deep understanding of the formalisms and rules you learned before. And so as we develop Rust, something that we've realized very quickly is that in a way that you might not realize, it would seem surprising, is that beginners and the advanced folks actually tend to want the same thing. They want the ability to tinker with things, to have like things be maybe more explicit. And it's really that group in the middle, that intermediate group, that's a lot more tricky. And so one thing that we noticed with Rust is that we tend to build features for the survival and sophistication stages. And that's really quite interesting because the folks in the inquiry stage find this incredibly frustrating. They do not care for this whatsoever. And this is partially one of the things that we're kind of looking at as we create these domain working groups and work at coming up with ways to get intermediate developers more interested in Rust. But you can already hear that I'm saying that we're already messing up, and it's because we don't have all of the answers, but we are trying our best to ask the right questions. And so fundamentally for us, if we really want to do this web server thing, we need to answer the question, can Rust achieve the ergonomics and productivity required to make systems level control viable for web development? And the easiest way to say this is, can the experience writing Rust be good enough that I could convince you all to leave Node and go to Rust? And that's a really hard question. So you could look at this survey and it could be like, job done. All right, so Rust has been the most loved programming language in the Stack Overflow survey for 3 years. It's a little confusing, actually. But you know, surveys also Stack Overflow, and let's tell a different story. So this is a blog post on the Mozilla Hacks blog by Vic Fitzgerald, who's the lead of the Bazaar working group, and he wrote it, and it's called Oxidizing Source Maps with Rust and WebAssembly. And so what he did is he took the source maps library that Firefox is using, and he rewrote it in Rust and compiled it to WebAssembly. And it was super fast, very fast. There are a lot of graphs in that blog post, I'm not going to make you look at them. The takeaway is that it's extremely fast, and it's very good. Now, inevitably, when someone said, I rewrote something in X and it went faster, someone else is going to go, but actually. And so, this person wrote, maybe you don't need Rust and WASM to speed up your JS, because maybe you don't need jQuery is getting kind of dull, and we needed a new, maybe you don't need. And so, the thing is I kind of love this blog post, and if you are interested in V8 and V8 optimizations, like check out this blog post, because he ends up writing JavaScript that is just as fast as the Rust compiled to WebAssembly, really just as fast. It's an incredibly long blog post and there's a lot of code in it. And I think it's really a testament to the fact that V8 is really good for you. Anyways, I always do this just to piss off Benedict mostly. But yeah, I mean, V8 is doing a lot of amazing optimization work, and if it was a competition, I would say, oh, maybe Rust and WebAssembly are like racing V8 to see who can be faster, because the optimizations that they're able to do in your JavaScript are really making JavaScript fast, and that's super cool. But also, it's not a race, we're all here to like hang out in the browser together. But what I really loved was Vic Fitzgerald's response to this incredibly technical, incredibly complicated blog post, was a post called Speed Without Wizardry, and I just want to read a bit of it to you. So he says, the oxidating article recounts my experience integrating Rust compiled to WebAssembly into the source map JavaScript library. Although the JavaScript implementation was originally authored in idiomatic JavaScript style, as we profiled and implemented speed improvements, the code became hard to read and maintain. With Rust and its zero-cost abstractions, we found that there was no trade-off between performance and clean code. So again, the previous person was able to make their JavaScript fast, but I have to imagine that if you've been doing JavaScript for any period of time, if you're trying to do a lot of speed optimization work, you're often taking your code from being extremely readable and maintainable into something that's a lot more complicated to read, and it's really more complicated. goal. And so Rust's goal is you should be able to write idiomatic code, and it should just be fast. You shouldn't have to worry about, all right, come on. All right, this is a bummer. Let's just do the plug it in, unplug it thing. Shield your eyes. Shoot. All right, well, I'm just going to keep talking because you can read the slides later. All right, so the real question is, how did Rust get here? This is the real talk about, like, what is the journey to where we are? And so one of the most, I think, interesting things about Rust is how Rust does its open source. All right, I need this to actually be up, at least. All right, and so this would be a picture of the core team. Now it's a glitched out picture of the core team. But what it's worth knowing is that there are several people on the core team, but there are like more than 100 folks actively working on the top level teams in Rust. There are a lot of people working on Rust and a lot of people who have influence over how the language is designed. And so we kind of follow this idea of why wasn't I consulted? And I don't know if any people here have actually read this blog post, but Paul Ford writes, why wasn't I consulted is the fundamental question of the web. It is the rule from which other rules are derived. Humans have a fundamental need to be consulted, engaged, to exercise their knowledge and thus power, and no other medium that came before has been able to tap into that as effectively. All right, and so Rust sees this and doesn't go, oh no, this is a huge problem. Instead, what Rust says is, we need to consult with everybody. And for the open source maintainers in here, maybe you're like, oh no, that's a nightmare. Like, oh no, maybe it is a nightmare, but let's hear about how we do it. So all major decisions in Rust, and we say major because there's all different types of major decisions, are preceded by something called an RFC. And the main goal here is that it's also kind of documentation. We're able to write down all of the reasons why we do any of the features that we have to Rust. And the key thing here is that all of our RFCs are consensus driven. So if there is not consensus in the people who are talking on this RFC proposal, it's not going to happen. And we wait and we work through those conversations to reach consensus. And one of our biggest ideas is this idea of no new rationale, which is that designs that rest on, every decision we make needs to rest on a prior public debate. So there's no new ideas. There's no coming out of the woodwork being like, we're doing this because we had a conversation in a closed door room and this is how it's going to go. And the reason we came up with this idea is because that's how it used to happen and people got mad. Now you can contrast this idea with how a lot of languages or other open source projects make decisions. So this is a quote from the Apache Software Foundation where they use an idea called lazy consensus. And it feels almost absurd that projects actually use this when I read it. Lazy consensus means that when you are convinced that you know what the community would like to see happen, you can simply assume that you already have consensus and get on with the work. If people don't like it, they'll let you know. So that's a way that some things actually get done. I would not recommend it though. So one of the big things that Rust focuses on is articulating its vision. It's hilarious because in JavaScript we're like, oh my god, there's so many thought leaders. But it turns out that we actually don't do much thought leading, especially in language design, really at all. And the trick is that leaders, especially leaders of open source communities, need to expose their ways of thinking so that there can be understanding throughout the community. The goals of those leaders are to inspire the community towards a clear goal, establish shared values, and be able to identify and explain historical themes. And if this is starting to sound more like a humanities job than a computer job, then you're right, because there's a lot of those skills needed for this. So there is a book called The Cathedral of the Bazaar, and I'm not going to say who wrote it. There's a joke here about how that person's a big jerk. But this is kind of a useful idea, which is that every good work of software starts by scratching a developer's personal itch. And so Rust's roadmap process, where we define our goals for the language for the year, make it so that people understand what our goals are, and that we can all come together and agree on something, is primarily this idea of helping people itch in the same way. And this also is really helpful because it makes it easier to say no to things, which is a really important job. So this is our RFCs repo. You obviously can't see it, but there's some pretty huge comment numbers. And not only do we do RFCs for the entire Rust lane, but also for libraries. So this is the Tokio RFCs repo. These have significantly higher numbers, and it's blocking it exactly. That's amazing. So what you would see on this slide is that it's a screen cap of the Tokio RFC's repo, and there are 3 pull requests. 2 have been closed, 1 was merged, and they all have more than 100 comments, and one is called Tokio Reform, Tokio Reform, Tokio Reform Take 2. Because it turns out that we really do care about seeking consensus, and when people come in and go, this is bonkers and this is not going to work, we listen and we say, oh, we should step back and try and rethink this. So this is the async await RFC. This is an example. This one had 258 comments. And a bunch of GitHub emojis that you don't have to see. They stress me out too. And so what I'm trying to say is that Rust spends a lot of time focusing on getting a lot of people involved in the decisions around the language. But that's not always great. So there's definitely problems with scale. We have RFC threads that can get 100 civil, insightful comments in 24 hours. This is after we filtered for the ones that aren't. You can still get like 100 awesome comments in 24 hours. And so there's an intense amount of information overload. There's so much out there, no one can find anything. And it turns out that people do not like volunteering their time to be a manager. It's really hard, and we need more of them. But fundamentally, this is positive because, not everyone will share values, not everyone will interpret the values the same way, but fundamentally making room for diversity of values is going to make a better product. So, what is the point of me saying all of this? So, the first thing is that I don't think Rust, especially its async story, would be the same if it were not for Node. I think largely Rust has been a response to Node. And Node.js exists for a very specific reason. Ryan was responding to very specific conditions of the time when Node was invented. And yeah, Rust is at least partially a response to that. However, I think that there are ways that Node and JavaScript can now also kind of respond to Rust. And so this is where it's a little testy. But as I kind of mentioned, Node and JavaScript have not re-articulated their goals and their audience in a really long time. I cannot find these goals. Maybe they exist, but I have not. It's hard to find them, and in general, I was on the board, and I don't know what the goals are. And Rust also definitely has room to improve here. We have yearly roadmaps, but we still kind of don't know the answer to what is our overall vision. And a lack of overall vision is bad. We're all working extremely hard, but have we paused to be to what end? For who are we making this stuff? And a lack of vision causes, at best, a mismatch in expectations. I wanted to share this blog post. It's by someone who works on a language team called Without Votes, and it's called Not Explicit. And it's about walking into language conversations and just complaining that you don't like it because it's not explicit. And this is an example of where Rust has failed, because a lot of people fundamentally believe that explicitness is a value of Rust, but we don't actually document that anywhere. And also, what does explicit actually mean? This is actually a really cool blog post, please check it out. But what I want to talk about now is that a lack of vision can have much, much worse implications than just people not understanding each other. So there's some amazing photos here. I'm glad you can see at least part of it. I don't know, can anyone recognize this from the photo? You already saw the slides. But yeah, this is Bjarne Stroustrup, the creator of C++. And he recently wrote a really amazing article. So he kicked this off by saying, most people in Working Group 21 are working independently towards non-shared goals. Individually, many, maybe even most, proposals make sense. Together they are insanity to the point of endangering the future of C++. So there's a little ableism in there, but it sounds like Bjarne is a little worried about the future of C++. And so his title of this article was Remember the Bossa, and I kind of love this metaphor. So the Bossa was this Swedish ship, and it's one of the largest, most heavily armed warships of its time. They were let's throw everything on this, every feature possible. Big ship that was supposed to really intimidate everyone. But at the beginning of its maiden voyage, on the 10th of August in 1628, the Bossa sank after only 1,300 meters driving distance in normal swell due to serious structural instability. So we built this huge thing, packed it full of features, and it fell over basically immediately in just normal conditions. And so what is the point of this? So Bjarne says, we need a reasonably coherent language that can be used by ordinary programmers whose main concern is to ship great applications on time. we now have about 150 cooks. He switches to another metaphor here, I'm not sure why. That's not a good way to get a tasty and balanced meal. So we are on the path of something that could destroy C++. We must get off that path. So this is a map that you can't see, so no big deal on that one. But what I want to say here is that ergonomics and productivity are the determinants by which the success of any programming language is going to be measured. And in order to get ergonomics and productivity right, we need our users to be in the room. We have to talk to them. There needs to be feedback. And so Russ Cox said this, we're talking more about diversity in Go, but he said to make Go successful, we need everyone's help, and everyone isn't here. And that can be about, certain types of people, but I think we can also think about it as like, how many people are we involving in our language decision process? And it was interesting to hear the talk this morning, because there was this question of Go, Go is kind of like this dictatorship. Node and JavaScript are really community driven. And I'm kind of here to say, maybe it's not. So I'm a little bit worried about JavaScript and its language direction and getting more people involved. And it goes back to this first programming languages article, which I kind of just stumbled upon Googling genealogy, but it ended up being very useful. And so in this paper they say, the major problem caused by the unavailability of feature uniformity, aka you can write things in a whole bunch of different ways, is that the size of the language increases, which in turn results into a longer learning curve. This leads to an increase in the language complexity in the terms of the number and type of constructs. Resultantly, a language without feature uniformity usually demands the instructor to teach a subset of the language. A programmer can use this subset for writing code, but for reading others' code, comprehensive knowledge is required. And so I bring this up because I'm a teacher and I loved teaching JavaScript. When I was supposed to be teaching Ruby, I would switch into JavaScript because it was such an excellent teaching language. And I'm a little sad that maybe JavaScript is becoming not a great first programming language. I'm not saying it's there yet. I'm not saying that the sky is falling. I'm saying that there's maybe a chance that we're heading in a direction that this is the case. And the main reason I'm sad about that is because if it is true, I think it's happening by accident. I don't think anyone is intending for this, but I think that currently, because of the lack of an overhaul and coherent vision for what JavaScript wants to be, we're kind of throwing out features without that coherent vision. Maybe we're becoming a little bit like a Bossa. And so what I'd like to say is I'd love to see all language communities better articulate their visions. Pick who you're writing this language for. Know why you are writing the language. And to do that, it's often going to mean that you need to see requests for feedback from a wider range of people. And yeah, that's not fun, and it's definitely super uncomfortable, but it's the work to be done. Even just look at politics today. Getting a large number of people to talk in a reasonable way and reach consensus is a hard problem. And we have the opportunity, particularly in open source with language design, to start trying out ways to solve that. And so I'm really excited to do that, and I hope more folks will join us. Thanks.